In 1 second, the Sun produces enough energy to power Earth for 1,000,000 years. But where does this incredible power come from? Well, the answer is nuclear fusion. But what is fusion? Well, stars like our Sun are mostly made of hydrogen plasma, a hot soup of hydrogen nuclei, basically just protons, and electrons. Nuclear fusion happens when hydrogen nuclei bond together to make a heavier helium nucleus, releasing huge amounts of energy as light and heat. But why does nuclear fusion release so much energy? Well, imagine what would happen if two rockets collided at high speeds. The collision would release huge amounts of energy. Well, something similar happens during fusion. When nuclei get very close, they're pulled together by the strongest force in the universe, the strong nuclear force. The nuclei then collide at enormous speeds, releasing huge amounts of energy, just like those two rockets. But getting two nuclei to fuse is very difficult. You see, the strong nuclear force only kicks in when nuclei are very, very close, 100,000 times smaller than an atom to be exact. But because nuclei are both positively charged, they naturally want to repel each other. So how do stars force two nuclei that don't want to be near each other to get close enough for fusion to happen? Well, the answer is gravity. Stars are very, very heavy. Gravity pulls all that mass to the centre, creating enormous pressures in the core. How enormous? Well, imagine the pressure of Mount Everest resting on your head. This pressure in our Sun forces 4 hydrogen nuclei close enough for the strong force to take over. They then fuse into a helium nucleus, releasing huge amounts of energy. But that energy still has to come from somewhere. So finally, where does the energy released by fusion actually come from? Well, the answer lies in the equation E equals mc squared. It basically says that a small amount of mass contains a huge amount of energy. For example, if you converted the mass of a single brick into pure energy, it would equal the largest nuclear bomb ever detonated. But how does this relate to fusion in stars? Well, as already mentioned, 4 hydrogen nuclei fuse into a single helium nucleus. Now logically, you would expect the mass of 4 individual hydrogen nuclei to be exactly the same as a helium nucleus. After all, they're made of the same stuff. But in reality, a helium nucleus is actually lighter than 4 individual hydrogen nuclei. So what's happened to that missing mass during fusion? Well, it's this missing mass which is directly converted to energy. This is where the power of stars comes from. In fact, the Sun converts the equivalent mass of 100 Great Pyramids directly into energy every second. But what happens when a star runs out of hydrogen? Well, watch the next video to find out what happens when a star dies.